Hello, Yashika. Hello. All right, everyone, let's get started. Thank you very much for joining in. And today we are doing a little bit of harder topic. So are you guys ready to absorb this? This is very, very important. Okay. All right, Tasha, I'll try to remember that. Okay, not a problem. Hello, Nirav. Right. So we have in our previous lesson we did distance, speed, time graphs, right? So we will do a revision of that at the end. If you missed that lesson, please go through the platform. It is already there for you, so you're in line with this one. But you don't need to know anything that we learned in our last lesson for this. But this topic is super, super important. I keep saying that for every topic, right? I guess every lesson I say that this is important, that is important, because questions come from there. All right. So let's look at it. Did anyone do skydiving at all, or have you guys done that? Anyone? I don't think so. Rihanna, you have? Really? Wow. Now you want to. I have not. Okay. Okay. All right. Now, you see, we're going to study about terminal velocity. You did this topic last week. That's great. So we're going to study about terminal velocity, but I'm not just going to teach you what it is, but we are going to derive some equations, and we are also going to understand past exam questions and try to give some answers to it. Okay, are you guys ready? Let's get started. So before we explain all of that thing, I would like to explain to you about resolving forces and acceleration. So let us say there is a box. There is a box here, okay? And this box is on a rough plane. This is the plane we have. And what we're doing is we are applying some force here. Let's say we are applying 700 Newton there. And as friction, okay, there is some roughness on the surface. As friction, we have 300 Newton. What is the resultant force experienced by this box? So someone is pushing. Absolutely. Yeah. Can everyone understand this? Now, why did you guys subtract this? Afaq, how are you get 200 Newton? How did you get that? Yeah. Now, you see, 700 Newton is acting this way, and 300 Newton is acting in the opposite direction, correct? So, because forces is a vector quantity, which means you have to specify direction. And how are we specifying direction in this figure? Can you guys tell me? How are we specifying the direction? Of course, the arrows, right? The arrows is telling you the direction. Okay, now watch this. Now, what do you guys think? Because one force is more than the other, what do you think will happen to the box? The box will stay there or move? It will move. Not just move, it is going to accelerate. All right. That is Newton's law of motion. F, the force we apply, is equal to the mass times the acceleration. Correct, everyone? Did you guys understand this? Isa, very good. Now, watch this. You see this force here? We can now break it down because it's not one force that is applied. We have two forces, but they are acting in the opposite direction. Is everyone with me? Because if you don't understand this scenario, you won't understand terminal velocity. Okay, so if you didn't understand, let me know. So this same force, could we write 700 minus 300 here? Is that okay? You see that F itself, we broke it down. Is that okay, everyone? Yeah? So 700 newtons minus 300 Newton is equal to M is the mass and A is the acceleration. So we are saying that this box is going to accelerate in the direction of your resultant force. Did that make sense? It will accelerate in the direction of the resultant force. Where is your resultant force? This is your resultant force. Addy, over here you will have 700. 300 is in the opposite direction. That's why we are subtracting. So we have 400 Newton overall. Okay, overall 400 Newton acting where? In that direction. So the box is supposed to accelerate in that direction, correct? So now the acceleration will depend on something. What do you guys think? The acceleration of this box will depend on something. Of course, it will depend on how much force is applied, which let's say it's 400 Newton for now, but it will, guys, so some of you guys are saying, Afaq, you said, Anway, you said friction. Friction is already considered when we calculated this force, right? But something else, what do you guys think? Something else depends. Diani, correct. Sharia, why is there a question mark? It is the mass of the box, right? How heavy is the box? Okay, so the heavier the box, the acceleration will have to be lower. So that is the mass times acceleration. Now, we're not going to work out what it is. So this is forming a simple formula, F equals ma. How many of you have learned this? You must have. Don't tell me no. You have. Okay. Now, let's forget this scenario. Let's forget it. Let us think of the same box falling down. Okay, free fall. Let's say it's a parcel which just dropped off from the flight. Okay, it's a scenario. Now, what's going to happen? There is something that is acting down, and I've drawn an arrow mark. What do you guys think it is? It is not the gravity. So most of you guys are saying the gravity. Gravity is a type of force, but it is something else. Because of gravity, it is the weight. Absolutely. The weight, not the mass. Don't say mass. Okay. Mass is the amount of matter that is there in a substance, correct? But what is weight? Your weight can change on Earth and it will be different on Moon. Did you guys know that? How many of you knew that? The weight is different on Earth and different on Moon, different on Mars. It really depends on gravitational pull, correct? Okay, so this is the weight. Now, weight is measured in Newton. So although, please don't be confused when I say what is the weight of the potato or what is the weight on that dumbbell, we are referring to mass, okay? We don't, in normal English, we don't use mass that much. It's always weight we use. So now, in the free fall, there is weight acting. So let us say this box just started to fall. Okay? So Nikki, the weight is a force with which Earth is pulling the mass down. Okay? So weight is a force, mass is not force. Mass is the amount of substance that is there. Got it? All right. So watch this. Now the box is falling down. Initially, it is accelerating because it is, what is the acceleration here? The acceleration is 10 meter or 9.8 to be more specific. Acceleration is the value of g, all right, which is 10 meter per second square. It's not meter per second, Karthika. It is meter per second square. What is this 10? In fact, it is not 10. It is 9.81 to be specific, but we say it is 9.81. This is a constant value for Earth. So any object, whether it's a feather or whether it's a massive airplane, the Earth will pull it down with the same acceleration. Okay, it is not Newton's. It is meter per second square. That is the acceleration with which Earth is going to pull any object down towards the surface. Okay, this is a constant value, and this is worked out. So in GCSEs, yes, we can use 10. I just wrote it down to be more specific. Okay, now watch this. So while something is falling down, okay, what do you guys think? Waiga, it is not 9.8. The weight is not 9.8. So I guess you guys are getting confused. This is the acceleration, which is different to the weight, okay? Did that make sense? So there is weight, but it's accelerating. So of course it is going back. Of course it's going to increase the velocity because it is accelerating, isn't it? It is accelerating down towards the earth. So what does that mean? So let's keep two checkpoints. From that point, this is a checkpoint, and this is the surface of the earth. And that's the height in between. Okay, let's imagine it's about 20,000 meters, 20,000 feet high. Okay, very, very high. So it's falling down. What do you think will happen? What is this yellow arrow mark showing? Absolutely. Some of you guys are getting it. Yeah. It is the air resistance. So we have air resistance or wind resistance or whatever you want to call it. It is not the normal contact force, Karthik. Normal contact force needs to be on a surface. It needs to have contact, correct? This one, of course, it is a contact force. It is not normal contact force because it's falling down. This is the drag, or we let's call it drag. Air resistance is correct as well. So drag or air resistance is equal to each other. Now, I have put the... Do you see the length of the arrows here? The yellow arrow is a bit shorter, okay, than the weight. What does that tell us? The arrow. I've drawn the arrow. The yellow arrow is a bit shorter. Ethan, I will come back to what is normal contact force. Wouldn't the acceleration and risk? Yes, Karthika, very good. Okay. Advitya, it's to be more accurate because that 9.8 is the accurate one. You see here, I have drawn the smaller arrow mark because the drag in the beginning is smaller than the weight. And that is the reason why it is accelerating. So when something is falling down, guys, it is accelerating. What does that mean to you? When something is falling down, it is accelerating. What does that mean? It is moving faster. So as it falls, the speed is increasing quite a bit, isn't it? Right? Yeah, the speed is increasing. So when the speed is increasing, the drag will also increase. So I'm going to show you the same box. It went down a bit more. Now, is the weight going to change? Do you think the weight will change? The weight will not change. Notice that. But now, do you see the drag? I've drawn the arrow marks to be the same length. Is everyone with me on this? Are you guys with me on this? Look at the length of the arrow mark, which is now equal to the weight. All right. So I have a specific condition for you guys to look at, and then we will look at questions. We are going back to the same scenario. You see the 700 Newton over there? What if your friction was 700 as well? Will the object move initially? Okay, the object will not move. Why? Because it is the forces have cancelled out, correct? But in this case, in the box which is falling down, the box is already in motion. So when you have the drag and the weight equal to each other, the box is not going to accelerate anymore. It will go down with a constant velocity or constant speed. It is still going to descend. Okay, I'm not saying it will stay in the air. No way. It is going to fall, but fall with the same force. not necessarily like a balloon. It's going to fall down with significant force. I mean, sorry, the velocity, but the velocity is not going to increase anymore. Are you guys with me on that? Yeah. So and by absolutely less acceleration, the acceleration have gone down, the acceleration has reached zero. So this speed where drag is equal to the weight, when it happens, when the drag and the weight are equal to each other, we will reach terminal velocity. Okay, we will reach something called terminal velocity. Any questions? So when the drag is equal to the weight, by the way, all this information is inside the textbook. I'll show you in just some time. With the tip, I'm not too sure, Nethil. Nethil, that question, that is to deal with the center of gravity. Okay, which is not the same as this one. Okay, did everyone understand this concept? Kind of clear? Okay, now let me take you to the textbook and let's go through the graph and understand the graph. The exact same graph is going to come up in exam. So, Advitya, that's what I'm saying. If the box reached terminal velocity, it is not going to accelerate anymore. It will come down with the same speed. That's all. It is not going to stay in air. Okay? So let's understand this. So imagine this is the velocity time graph of what we looked at, which is the box. So the box was, in the beginning, it's dropped from maybe a helicopter or whatever. What is happening? Look at this. Please pay attention. You see that from 0 to A, we have large acceleration because it's accelerating really fast. Okay? And from A to B, what I'm saying is this entire part, A to B, what will happen? The acceleration, you can see the acceleration, it was supposed to increase the speed. What I'm saying is I would like you guys to have a look at what is written on the y-axis. It is the velocity, the speed of the object. It was supposed to increase proportionally, right? But instead, what's happening now? The speed is still increasing, but not as steady. So it doesn't tell you steady acceleration. The acceleration is reducing. And from B to C over there, right here, do you see that? There is no more acceleration. It is, if I go straight, it has reached some sort of velocity over there, and it is the same velocity. It is not going to increase any further. And that is what we call as the terminal velocity. Okay, so when you have terminal velocity, do you have acceleration? When you reach, absolutely. So when you reach terminal velocity, acceleration is zero, which means the sum of forces are equal to the sum of forces. The weight and the drag is equal to zero. Clear? So this is about parachute opening. You don't need that. When the parachute opens, the surface area has increased quite a bit, right? So the speed will increase. It's going to slow you down. That's what's happening. And this one is the parachute gliding down. This is not terminal velocity. It is controlled velocity, okay? So they have controlled the velocity and then going down. So what is important? You need to, let me show you. You see this one, let me zoom out a bit. You see the graph A to B and B to C. They have explained that over here, what is happening. Okay, A to B, let's quickly go through this. A to B, the effects of air resistance make her acceleration less and the gradient of the graph gets less. But she continues to accelerate as her weight is greater than the air resistance. So what it's saying, all this way, she's continuing to accelerate, the skydiver. Okay? and then the resultant force is downward. So overall, at any point from 0 all the way until this point, the resultant force, when you add it up together, there is a resultant force downwards. It's not equal to 0. Now, what is important is the next sentence. Watch this. BC, which is this part, all right, guys? BC. The air resistance now has increased so that it is the same size as her weight. The resultant force is 0. She moves at a constant velocity. This is terminal velocity. I want to highlight some key words. You need these keywords in exam. Number 1, it's the same size. Not same direction, same size, which means the magnitude. So what is it? The air resistance. You need the word drag or air resistance is the same size as the weight. That must be conveyed clearly. And then you also need to write this sentence. The resultant force is 0. It's a must. I'll take you through some past exam questions in some time. Okay, you want to write down the resultant force is 0. Key text. And that's why we are reaching terminal velocity. Is this clear to you guys? The concept. This is the concept of it. And that's it. You don't need to learn terminal velocity again. Yeah? Did everyone understand this? Just say yes if you did. Perfect. Okay, great. Yeah, so yes, no problem, Sharia. So simply put, falling down, if you're biking, you can reach terminal, terminal velocity can happen even when an object is moving horizontally as well. All right. So say, for example, uh, if I'm driving, I've just pressed the accelerator. I'm just going to test the speed of my car. I press the accelerator, the car will keep going. It reaches 70 miles an hour, 80, 90, 100, 110, and then it's not going to go. Maybe it might reach 120, but it will not go further than that. Okay, although the engine is putting that. Why is that? Because the force produced is opposed by the air resistance. Did that make sense? Yeah. No, even if the engine is constantly working through, but the force backwards, the air resistance you will experience is opposed by that. Okay, so the net force, there's no more further force you can add onto it. Okay, that is terminal velocity as well. So in the textbook, you can have say, for example, this is not very important, but I have seen past exam question of this. Look at this. In here, we have a metal ball which is dropped in glycerine. Can anyone say what is glycerine? Well, I mean, why do we need glycerine? Why not water? Yeah, it's a liquid, of course, yes. I don't mean what is glycerin. Why are we using glycerin? Because it's denser. We call it it's less viscous. Okay, it's kind of thick liquid. So what happens? The ball is not going to just get dropped. It will go with the same velocity. It's just going to fall with this constant velocity. Okay, so that's one of it. A ball bearing falling through a thick liquid like glycerine reaches its terminal velocity before an identical ball bearing falling through air reaches a faster velocity. So if an object is passing through a a medium like air, water, or glycerin, for example, in this case, it can reach terminal velocity faster. It really depends on what it is. Okay. All right. So I'm going to take you through a past exam question on terminal velocity. Let's see how this is done. Just a second, guys. So an object Can you all see this? Just say yes if I switched between PDFs. Yeah? Okay. An object in free fall eventually reach terminal velocity. It just says an object in a free fall eventually. So I'm going to draw the object. This is our object, okay? Okay, cool. Draw a label diagram to show the forces acting on an object when it is falling at terminal velocity. So when you're drawing the label diagram, what do you think you should draw here? Okay, I'm drawing an arrow mark. Okay, what would you write? This arrow mark. This is the weight. Absolutely. I would also put Newton in there, correct? Okay. I would also draw another arrow mark, but be careful. You will lose. Why is this 3 marks now? I'll tell you the breakdown. What is this? This is air resistance. It's a free fall, right? It says free fall. So it's falling through air. Air resistance or drag. Now, this is 1 mark. This is 1 mark. Where is the third mark coming from? Absolutely, guys, you guessed it. If the arrows are of different size, the arrows need to be of different size. If you draw arrows of different size, you will lose a mark. Did you guys know that? You see, now you know it. It's important, the size of the arrow mark. I mean, they're not going to measure with a ruler, but it looks like it needs to be kind of the similar size, because the arrow mark shows the vector quantity, right? I have someone asking me why. Very good question. If this is 100 Newton shown by an arrow mark, this must be 100 Newton, correct? This can be shown by vector arrow marks. So the length of arrow mark, we could say 1 centimeter is 100 Newton. And in physics, we can draw vector diagrams, which we will learn later on. And it also need to have correct direction. Very good point, Ganesh. We need to have correct direction. If the direction is switched, you will lose marks. Sam, please ask. The object, it doesn't matter. You can put a ball like this, a dot. It doesn't matter. Okay, that is not having an issue. Okay, so that was 3 marks. Let's go down. Now let's look at this. A student measured 2 forces, 5 Newton, 3 Newton. The forces act at 90 degrees to each other. Determine the resultant force. How many of you guys, this is, by the way, this is coming from, you need a ruler with you, okay? Aerodynamics. That is slightly different to it. I will explain to you in some time. If the arrow don't look the same, label. Can you label as equal length? Amish, you don't need to label it. You need the diagram. You need the arrow mark to be of the same size. Okay? You've got to have the arrow mark. There's no point in labeling. The arrow mark should be the same. Right. So let's look at 1.2. The forces 5 Newton and 3 Newton, they're acting at 90 degrees to each other. What does that mean? So we have 5 Newton. Let's say it's acting vertically. This is 5 Newton. And we have 3 Newton, which is a bit more smaller. 3 Newton. Would you all agree this is acting 90 degrees? Yeah. If they're acting 180 degrees, they are acting like that. Okay. Now, the resultant force is basically this red line. This is the resultant force. So how would you find the resultant force? How would you do this? This is maths now. This is Pythagoras, right? Absolutely. So the resultant is R. R square equals 5 square plus 3 square. R square equals 25 plus 9. You got to find R, right? Which is square root of 34. Square root of 34, 5.8. Okay, everyone, did you guys get this? So, yes, absolutely, we can have Pythagoras. Now, there is a resultant force. So, say, for example, this happens quite a lot, guys. I'll give you a quick example about what is resultant force. How many of you have good understanding on what is resultant force? Yeah. Okay. Look at this. Let's say this is a spider. Um, okay, and it's crawling down. Now, what do you think this arrow mark is representing? That arrow mark. It's the weight. Would you all agree with that? Yeah, measured in Newton. Okay, no matter how small the spider is, there is a weight on it. Now, according to its weight, you see the red web, it will have something called tension. Would you all agree? Yeah. There is something called tension. It isn't tension because it's hanging on it. Okay. Now, what's happening? There is some wind. All right. There is a bit of this arrow mark is basically wind. All right, wind. Now, what do you think will happen to the spider? Yeah, the spider, would you all agree the spider would go this way, right? It would be there because the wind has pushed it. So resultant is you have a vertical force and we have a horizontal force, correct? And therefore, now the resultant is in an angle. There has been an angle formed. This is the angle formed in between. Did that make sense? I'll give you a quick another example, and it's more better. So this is the idea of resultant force, but I want to give you a quick example. You see, this is a ship, all right? Ooh, that doesn't look like a ship. Okay, now this is a ship, and imagine this is the top view of the ship. The engine of the ship is forcing it to go straight. Now there is sea currents, all right, underwater currents pushing the ship this way. So the actual movement of the ship would be there. Did that make sense? It would go towards the right because there is an external force acting on it. So the ship, in fact, will, you know how it will move? Can you visualize this? It will go like this. It's moving forward at the same time it's moving a bit to the right. Did everyone understand this? Yeah. So what we do, the captain will have the right side engine to be on a different velocity so the ship can actually move forward. So they will correct it by some balancing forces. Okay. So this is the idea of resultant force. And so my point is we have two forces in action. Number one here, which is the vertical force. You see the vertical force, and we have a horizontal force, and what comes in between is your resultant force. This is how Pythagoras is coming up. So the vertical and the horizontal will always be 90 degrees. That's it. So don't worry about the direction at this point. That we will need to go through Sokotowa, which is out of the context, which is not there in GCSEs for you to look at. Don't worry about it for now, okay? But the resultant force, why we are using resultant force is from Pythagoras for now. So an object, let's look at 1.3, guys. An object traveling in a circle at a constant speed is changing velocity. Explain why. Ooh. This is a bit more further. So an object is moving in a circle. So let's say, I'll show you what that means. Let's say this is the object here. It's like a stone, and it is tied to the center of it, and it is going around. All right, its circle is at constant speed but changing velocity. What do you mean by that? uh Hira, it okay, I got you. It says it's acting 90 degrees, right? So how could it be in the same direction? Right. So this is our object. Okay. Now, here's the point. Do you think this object at this point has a direction? It's moving in that linear direction. At that point, it's moving in this linear direction. At this point, it is moving in that linear direction, right? Don't you think so? So as it's moving, imagine, how do I know it is moving in that linear direction? Imagine this is a rope, okay? Whatever I'm drawing in dark right now, the blue one, imagine that is a rope. If that rope was cut off, this object would move straight, correct? Did you guys understand this? So if an object is, even though it's going around a circle at a constant speed, the velocity is changing because velocity is what? What would you write? Karthika, you got it right. Velocity is a vector quantity and direction is changing. Okay, so Malachi, I know what you meant by centripetal force. We don't need to explain that, you see. It is because it's moving in a circular motion. Velocity is a vector quantity and the direction is changing. That's all we need. Okay, so this was about it was an attached question from terminal velocity, but let's go to another terminal velocity. Hailstones. All right, let's talk about some hailstone. Hailstones are small balls of ice. Hailstone form in clouds and fall to the ground. There are different sized hailstone. Which force caused the hailstone to fall to the ground? A, B, C, D. Which one is it? Okay, B. Now, guys, you see this question here. This question here is a simple one. Now, in a different paper, there is a different level of question, which I'll show you later on, okay? The same question in a different way. All right, next one. As the hailstone begin to fall, they accelerate. Don't you think? It's just like this is a hailstone. It's going down. They are accelerating. The weight is there. So the weight in Newton, it is going to accelerate. Which force increases as the hailstone accelerate? A, B, C, D. Yeah, A. It is not the gravitational force. Who said that? Gravitational force is going to be constant, never going to change all over the earth. Okay, cool. After a short time, hailstone fall at terminal velocity. So what's happening now? The hailstone is here. Oh, sorry, we have already drawn one. Let me move that one. So this is our hailstone. It has got the drag or the air resistance, right? Which of the following statement is true? One or A, B, and C. The hailstone begin to slow down. The mass of the hailstone increase. That is not possible. The resultant force of the hailstone is zero. Absolutely. Drag is equal to the weight. They're opposite. Resultant force is zero. Okay, now we have a graph given. Scientists investigated how terminal velocity of hailstone vary with their diameter. So here we have a hailstone. Here we have a hailstone. Okay, small one, bigger one. Now this is the diameter of it. This is the diameter of it. Okay. So they were trying to study the terminal velocity. Okay, what are our study parameters? You see how terminal velocity of the hailstone varies with the diameter. You can see terminal velocity on one side, diameter on the other side. Okay, so generally, what could you say about this? What could you say about this? It's not a straight line. It's almost kind of like a straight line. What do you guys think? As the diameter increases, the terminal velocity would. What do you think? Yeah, it's kind of, you can't say proportional. Can you say this is proportional? Why not? Why can't you say this is proportional? There's 1 point missing, only 1 point missing. It, Dakshina, it is not a straight line, but imagine it was a straight line. There is one important part that Advitya, you got it correct. Sudipta, you got it correct. Okay, now you guys are getting it. Pretty much everyone is saying the same thing. It does not start from zero, right? So we need, if it is proportional, it needs to start from zero. Did that make sense? So do not write, if they ask what is a relationship, don't write proportional. They're directly proportional. You will not get marks, okay? So let's go through. Estimate the terminal velocity of the hailstone with a diameter of 80 mm. Show that how you obtain your answer. So what are you going to do? You see this 80? You're going to estimate it. So what we're going to do is we are just simply extending this thing, just like that. Can we do that? Can we do that? Yes, absolutely. Okay, why can we do this? There was a specific topic for this in maths. It's at the tip of my tongue. Okay, I'll come back. I'll tell you when I get it. Okay, absolutely. So this could go further, and then we could just get to that point, 80 to there, and draw it. But 20 equals 15. Very good, Yashika. 15 times 4 would get you, so it would be 60. Okay, it is following the trend, correct? So roughly, if your answer, there is I've checked the mark scheme, it would come between 45 to about 55. If your answer is within that, you should be all right. Okay, so now look at this. Give one reason why the hailstone with a larger diameter has a greater terminal velocity. A, B, C, D. Greater weight. Absolutely. We didn't talk about the word power, pressure, temperature, right? It's the weight. Easy answer. Okay. Now, after falling, the hailstone hits the ground. So the hailstone hits the ground now. And figure 5 shows the forces acting on the hailstone at the moment. What does that mean? At the moment. At this point, Jay, no. These are some simple questions which I've grabbed together. What does at the moment mean? It means at that specific instant when it is making contact with the ground, not after, or after the collision. Okay, Ganesh, absolutely. It is the point of collision as it happens. What is the magnitude of the resultant force? You just need to subtract this, right? So that would be A, B, C, D. What is the value? So 63 minus 15, 48, which is B. Easy question. What is the direction of the resultant force on the hailstone? It's simply upwards. Simple questions. Now we are going to do higher paper 1. Same question, but different way of asking. So what we did before was easy. Would you all agree? That was picked up from foundation paper, just to give you guys some idea of what's going to happen. Now, the same question is from a higher tier paper, okay? Now, of course, I know you guys are not doing foundation for science, but I just wanted to show you the difference in there through a question. So hailstones are small balls of ice. They form in clouds, fall to the ground. This is a brand new question, okay, which came up in the same place, same paper. Hailstone falls from cloud and accelerate. Why does the hailstone accelerate? Very good. So hailstone is irregular, meaning Advitya, no, that won't be the answer. Why is accelerating? Okay. Why did the box accelerate? Do you guys remember the box? Yeah, we had the box. Why did this box accelerate in that direction? Yashika, think about it. Think about it. Why does it accelerate? Okay. Hold on, hold on. The chat went so quick. Akash, you got it correct. A greater. Okay. Karthika, you got it correct. Uh, Banu, you got that right. Okay. Anway, you got it right, but you want to weight is more absolutely than compared to what? Okay, absolutely. So, guys, listen. Acceleration happens when there is an imbalance in force, correct? So, if this is the force and this is friction, if this was 700 and this was 400, this is 700 minus 400, which is equal to 300 in that direction. That's when you accelerate, right? So the hailstones are accelerating because the weight is more than what? The weight of the hailstone is more than the drag. Put in a nice sentence and you're done. Hira, doesn't it also gain? Of course, yes. So when it says accelerate, it's all throughout acceleration. It's gaining speed. Get it? So it's accelerating means the speed is increasing as time passes by. So my question here is, look at the question. Why does it accelerate? Why would anything, not just hailstone, why would anything accelerate? Because there is an imbalance in force. So in this case, you want to look at what is happening to the hailstone. There is weight, right? And there is some drag. Now, because the arrow marks are smaller, the drag is smaller. That's why it will accelerate down. Get it? Did that make sense, everyone? Now, anyway, the drag and resistance are the same thing. Yes. Yes. Air resistance. This is air resistance. Okay. I wouldn't say imbalance of force, guys. Adi, because this is specific to the hailstone, right? It doesn't say why does any object accelerate? Then you could. Get it? You see the difference? Yes, I would recommend you need these words. You need to write down the weight is more than the air resistance, hence the hailstone is accelerating. Okay, is this helping you guys? How to answer these questions? Very good, very good. You see, the result of this, you will only find it later on when you're actually writing the GCSEs. You probably have seen these questions already in your mocks. You will see it already. Okay, so next question. This is slightly harder. Let's see how this is done. Hailstones stop accelerating. Now, to answer these questions, you need to read the question really well. That's the first part of it. You got to read your question pretty well. Okay. So, hailstone stops accelerating, reaches terminal velocity. Explain why the hailstone reaches terminal velocity. This is a textbook question. Yashika, you don't need to put any quality sign. I just wrote it down to make it simple. Okay. This is a textbook question, and I'll show you where this is coming from. Do you see this part of the textbook? Okay. That is where the answer is. And this is why I would like all of you guys to read the textbook. We don't want to write, there will be a balance of a force. We want to write it a bit more. 3-mark question. So I've taken a screenshot already of this before. I'm going to paste it here. Watch this. So this is the screenshot of the textbook, which you just saw. I want to edit it a bit more. All right. So I'm going to write my answer based on this, okay? Watch this. So it's asking, Why does the hailstone reach terminal velocity, right? HS for hailstone, okay? Hailstone accelerates, accelerates, and its speed increases, okay? And what does its speed increase mean? This also means you could say the drag, or you could also write the air resistance. You could write as the speed increases, the air resistance increases. As the speed increases, the air resistance increases. Now we have an important point not to be missed. Then we will start from here. The air resistance have now increased so that it is the same size as the weight. The resultant force is zero. And the hailstone is at constant velocity. Done. We don't need this as well. So it's pretty much a textbook question. Does that make sense? Can you guys just read it through? Hailstone accelerates, its speed increases. As the speed increases, air resistance increases. So you could write it either way. The air resistance have now increased. It is the same size. You see that part? You need this. The same size is a must. You need that. You need to say the air resistance is at the same size as the weight. Therefore, the resultant force is zero. And this is how the hailstone reach terminal velocity. Becoming equal. Yes. So Ganesh, that's a good one. There's an equal resistance. Yeah, Advitya, that's fine, but we wanna write the resultant force, meaning okay, that's fine. Air resistance, Malachi, that is okay. Nettle, I that is completely out of context. I'll go through that later on. The acceleration air resistance will be same size because the hailstone can't go faster, increasing so the resultant force is zero. The acceleration, Karthika, the acceleration, it is not the acceleration and the air resistance, right? It's the weight. It is accelerating. Acceleration, air resistance, they are not. We cannot compare it. Did that make sense? Did you see it? Okay, great. Yes. Yes, you need to restructure. So how does it? Yeah, that's why Nettle stay up in the same place even though it doesn't get force from every side. What do you mean by that? Okay, resultant force. Yes. So pretty much all of you have responded with an answer that was good. Okay, you can put it in your own words. It just needs to make sense with the keywords. Make sense? The same size and the resultant force being zero. Okay, great. Now watch a different graph. Now the scientists investigated the mass before. Do you guys remember in the previous question, it was the diameter of the hailstone and the terminal velocity? Okay. This one is the mass and the terminal velocity. Because was that ChatGPT? Because I see the dots. Hmm. No, you wrote it down. Okay. Okay, so that was points. Give me a second. Very good. Both directions. Velocities, vector quantity. Okay, you don't. Okay, here's the thing. You don't need this amount of explanation. You can make it very short. Just need to be on to point. Make sense? When it comes to exam style questions, you don't need to write all of that. Yeah. So that is a lot of explanation in there. Okay. Made. Oh, okay. Not made on words. That's fine. That's fine. Okay. Not ChatGPT then. I use ChatGPT, by the way, guys. Uh, so I'm making some video for physics, animated videos So I type in my explanation and I give it to ChatGPT and ask ChatGPT to make it a bit more better. Um, and it does do it pretty well, actually. Anyway, so a scientist investigated how mass of hailstones affect their terminal velocity. Why does terminal velocity increase with mass? A, B, C. What do you guys think? As mass increases, the cross-sectional surface area of the hailstone increase, which can be a bit of, debatable thing. As mass increases, we think it's the size is increasing, and therefore the surface area is increasing. As mass increases, volume of hailstone increase, which is debatable as well. As mass increase, the weight will increase. So you want to bet on C. Why would you do that? Not A or B? Because we always talk about the weight being compared to the drag, correct? So we need C in this answer. Okay, so that was a simple one, but we have some uh not that great question coming up. Let's look at 3.4 really quick. Okay, 3.4. Explain the difference in the maximum kinetic energy of a hailstone with a mass. So what is kinetic energy, everyone? If you guys know it, say yes. What is kinetic energy? Energy with anything that has mass and it is moving. Anything. Okay? So, by the way, guys, the other day I found a tortoise and I tried to pick it up and put it to a safe place. And do you know what it did? I don't want to say it. No, it actually, so I picked it up. The face is like this, okay? I picked it up. It actually um, did number one onto me. It pissed on me. So on my it was on my shoe, by the way. I was like, what did you do? Yeah, I think it was scared. So I put it where it was. I was trying to save it, but it didn't work out very well. I know, I know. But anyway, things can happen. So explain the difference in maximum kinetic energy. My point with the tortoise was, so as soon as I put it down, I never knew it can run like that. It just ran like really fast. I don't know how that happened. It just went fast, really, really fast. Okay. So kinetic energy. Explain the difference between maximum kinetic energy of a 20-gram hailstone and a 10-gram hailstone. Now, they are very specific over here. So if I go back, what do you guys think? How would you answer this? The answer, there is a bit of answer here. It's from the graph. Now, here is the point. Sometimes in the actual paper, I want to show you that. In the actual paper, you see this graph here. It's in a different page than this question. Are you guys with me? It's not in the same page. So some students, I've seen some students trying to work out kinetic energy formula, mv square over 2. You see, they were trying to figure out, they converted the gram into kilograms and they went too much. Do you know why? Because the graph was in the previous page, they forgot there's a graph there. So because they completely didn't realize the graph was here. So we got to pick up, you got to use this graph to figure out the terminal velocity. That's it. So here we have 10, that is right there. And what is the terminal velocity if the mass is 10 grams, guys? That would be 4 meter per second. And if it was 20, that would be 32 meter per second. Would you all agree with that? That is pretty accurate, isn't it? Now, okay. So what does the question say? Explain the difference in the maximum kinetic energy. What is the difference, by the way? It is 28. We also say, when you want to explain it, how many times is it more? So when the mass was doubled, do you see the mass was doubled, 2x? What is that? It is 8 times more. Do you see that? You got to explain that too, which is not taught in every lesson. Okay, so these are the questions which can come out of nowhere. And this is the problem solving skill. And there is a specific part in physics. It tells you need to be reading the graph. Your ability to read off data from the graph, okay, is super important. So here, why would they give you 10 to 20? I noticed straight away, oh, it is 2x. 2x more. Okay, so we want to say, why would they, when I got 4 and that 32, I noticed 32 is divisible by 4, so it is 8 times more. So you could always write in there the mass, as the mass doubled, okay, from 10 grams to 20 grams. So as the mass doubled from 10 grams to 20 grams, the terminal velocity was 8 times more. Is that clear? That is your explanation about the terminal velocity when the mass is different. Is that clear? Do you guys see a difference in the difficulty of question from the previous one and this one? Akash, if you drop a bowling ball and a feather in a vacuum, they will not reach terminal velocity at all. They will just fall down because there's no air resistance. Yes. Okay. Very good, guys. So that is pretty much about terminal velocity. So these are all past exam questions based on terminal velocity, which I will upload. This document is already in the platform with the mark scheme. You can check it out. And terminal velocity is out of your way. Any questions for me? There's nothing further, by the way, from terminal velocity. You can take it all the way until year 11. There's nothing more than this. Any questions for me, guys? Sharia, thank you very much. Yeah, no, I just left it. It moved. It just ran off. Malachi, yes. Yes, Afaq, yes, I will confirm it. I will confirm in the morning with I'll message you. Oh, earlier. That should be possible. Yeah, I'll confirm the time. Uh, which 3 mark? Oh, this one. You have the 3 mark is distributed. Very good, Karthik. Here, reading of the data is 1 mark, 1 to 2 marks there. Reading of the data from the graph and then comparing it is another 1 mark. Yes, Ganesh, it should be there. Have a look. If not, I will let you know. Did you not have to sub in? No, here we don't have to sub in the formula because it wasn't asking you to work out kinetic energy. It was asking to find out the difference in maximum kinetic energy. And the mass was given, right? And we picked up the data and we just compared it. Okay. So we don't need to work out the kinetic energy. Did that make sense? Okay. Yes, very. No. The maximum kinetic energy. When would something reach maximum kinetic energy? Good question. The y-axis showed terminal velocity, isn't it? But you see here, terminal velocity, when something is moving, terminal velocity is the maximum kinetic energy. When you reach maximum velocity, that's where you have max kinetic energy as well. Did you get it? So terminal velocity means that's the maximum velocity will reach anyway. That's where the acceleration is stopping. Got it? So when they say in that question, let me go back, it's specifically asking you, hold on, maximum kinetic energy. Okay. Which is other ways telling you terminal velocity. Was that clear to you? Got you. Okay, everyone. I will see you guys. Thank you very much for joining in today.